The mystery of dark matter and dark energy. If you're the least bit interested in science and astronomy, you have probably heard of one or both of these names: dark matter and dark energy. They have fascinated astronomers, scientists, and astrophysicists for the past few decades and are considered two of the greatest mysteries in our universe. It should come as no surprise that the question most frequently asked by lovers of space or astrophiles is, what are dark matter and dark energy? But do scientists and astronomers really have a definitive answer to this question? Stick with us until the end and find out for yourselves. Hey everybody, welcome to the ThinkLab. If you're new here, be sure to subscribe and hit the bell icon so you don't miss any of our videos. Let's get started. What's the matter with matter? Wikipedia defines as any substance that has mass and takes up space by having volume. This definition includes trees, stones, stars, galaxies, atoms, and even ourselves. In short, matter is everything that has ever been known to us, living or lifeless. Matter as we know it only accounts for above 20% of the known universe. The remaining 80% is made of what scientists refer to as dark matter, which is, you guessed it, invisible. No wonder it has been so hard to discover anything about its nature for years. How do we know it exists then? You might ask Fritz Zwicky. A Swiss American astronomer was the first to suspect the existence of a missing mass in 1933. He discovered that the mass of all the stars in the nearest cluster of galaxies was far from the mass that was needed to prevent galaxies and stars escaping the cluster's gravitational pull. This missing mass remained a mystery for decades, until the 1970s, when two American astronomers confirmed its existence while observing a similar phenomenon in space. They realized that the mass of the visible stars in galaxy makes up only 20% of the mass that is required to keep them orbiting the center of that galaxy. They concluded that there must be a hidden mass in the center of the galaxy, one that makes light bend around it yet does not interact with it, meaning it neither emits light nor does it let light through. Since no light could be seen from this invisible mass, it was given the name dark matter. Keep in mind, however, that dark matter is not the same as antimatter, as the latter has the same mass as ordinary matter, but with opposite charge. If antimatter reacts with normal matter, unique gamma rays will be produced, resulting in the destruction of both matters. Simply put, antimatter is ordinary matter's archenemy. Dark matter is not a black hole either, because a black hole affects its surrounding violently, while dark matter just seems to be out there, scattered all over the place. It interacts with gravity but does not absorb, reflect, or emit any electromagnetic radiation. What is dark energy, and is it the same as dark matter? Now, dark energy and dark matter tend to be used interchangeably sometimes, as some people think they're the same. This cannot be farther from the truth. In contrast to both matter and dark matter, dark energy is uniform in space and time. Within the volume it occupies, dark energy is repulsive, not attractive, and certainly not yet well understood. Dark energy is a force that is making the universe expand at an unbelievably accelerated pace. It is the dominant component of the universe and has been present and at work even before the Big Bang. Wow, that's mind-blowing, isn't it? A late bloomer, dark energy was not discovered until 1998, when two international teams of astronomers used 8 telescopes to observe the expansion rate of the universe. They found out that the universe has been expanding at a much faster rate than in the past, which indicates both the existence and the dominance of dark energy. Before the recent discoveries, it was generally believed that the pull of gravity will eventually either slow down or retract the expansion of the universe, making it collapse on itself. We also know that dark energy is not a thing, but just a property of the empty space, which ironically enough is not empty at all. In fact, if we combine all the energies in the universe, the energy in the empty space still manages to surpass that amount. It goes to show that empty space is in fact quite active and has the potential to create more space, further proving that dark energy is getting stronger as time passes by. It is indeed stronger than what we can fathom with our human brain. What it all means for us. It might feel quite humbling, if not demeaning, to think about all the things that remain a mystery to us, things that we don't know and might not know for at least a few more centuries, or even a few more millennia. After all, we might ask ourselves, are we, with all technologies, victories, defeats, grudges, and bloodsheds, really anything but tiny little specks on a tiny little blue planet looking up at the night sky, contemplating what else could be there? For the time being though, let us take solace in looking at the full half of the glass. Coming even close to unlocking yet another mystery in the vast universe could perhaps help us get one step closer to finding out more about ourselves. Who we are, where we are headed, and what we are capable of. Perhaps by gazing into the silent darkness that surrounds us, we remember what matters to us the most, and what we should hold close to our heart. Perhaps the real wonder lies not in what cannot be seen, but what's visible to the naked eye. Perhaps matter is all that really matters. If you enjoyed today's video, give it a thumbs up and subscribe if you haven't already, and let us know down in the comments if there's any subject you want us to cover in the future. See you in the next video.